Alright, so first thing to note here, this is going to be stuff over 3.1 out of our book, which is talking about end behaviors of polynomials. It is going to flow into the next video, which will be talking about finding zeros of polynomials. The idea is we're putting all of this stuff together along with multiplicity. We did a bunch of stuff last week that we all kind of put together to use to graph out a function. So while this is a useful lesson, you definitely want to be watching the stuff where we're finding zeros of polynomials after this. Make sure you understand the whole process to be ready for the end of this chapter. But other than that, focusing on this specific lesson and behaviors of polynomials. So first off, polynomials, when we're talking about this, what I mean is we've already had lessons over graphing linear functions where we just have x to the first and have the straight line. We've already had lessons over graphing quadratics with the x squared. We're moving past that now. So the idea is these notes are supposed to be stuff that would work whether you've got next to the third, next to the fourth, x to the fifth, so on and so forth. That's the idea behind this. To be clear with this is not going to help you graph the entire function. This lesson is not for graphing the entire function. The idea is we know when we graph functions on a coordinate plane, we usually can't see every single thing that happens, right? Like if we just think about a quadratic, this right here is the graph of a quadratic. We can see what we're looking at on the graph, but there's more of the graph that's continuing on up here, that sort of thing, and we'll never be able to see the entire graph of whatever that function is because we don't have an infinite graph to be able to put this on, right? They just don't have enough screen space. So what the point of this is when we're talking about end behaviors is we're saying as the graph goes out of our sight, what's it going to be trending towards? Is this going to be trending upward like this quadratic is? Or is it going to be trending downward like a quadratic like this? Right? That's what we're talking about, is what is it going to be doing as it's going out of our sight? And so the idea is we can know how to graph quadratics, but we haven't talked a lot about graphing other functions, and we can't spend our whole year talking about how to graph an x to the third, and then next to the fourth, and the next to the fifth, so on and so forth. But there are trends that we can look at that will allow us to be able to determine what any type of function will at least begin to look like, no matter how high of a degree we have, how high of an exponent we have. So with that in mind, here's the idea for our end behaviors. We've basically got 4 different scenarios. We have to worry about our degree, and we have to worry about our leading coefficient. Now remember, degree is going to be I don't know if I spelled coefficient right or not, I think so. Degree is the highest exponent. Right, we're looking at the highest exponent on our x's to figure out what our degree is. Leading coefficient, remember a coefficient in general is the number in front of the variable, right? So if we've got like a 2x, then this 2 is our coefficient. The leading coefficient specifically is that number in front of the variable with the highest exponent. So it's not just a number in front of the variable. It's specifically the number in front of the variable with the highest exponent. Meaning, if we've got 2x squared plus 3x to the third minus 5x to the seventh, well, even though that's out of order, the degree would still be this 7 because it's the highest exponent. Since the 7 is the highest exponent, negative 5 has to be our leading coefficient. It's not about the number that comes first necessarily. Now, in general, you're going to see most functions given to you in standard form, and if they're not in the standard form, I'm probably going to ask you to put them in that form. So a lot of times it will end up being the first number that you see, but you always need to look because it's not required to be the first number. It's entirely based off where the highest exponent is and what number comes in front of that variable. But anyways, as far as our leading coefficient, we basically just run, it's called a leading coefficient test, or our end behavior test. And like I said, we are interested in our degree and our leading coefficient. If your degree is even or odd, that's what you're looking for. You want to decide if the degree of your function is going to be an even or odd number, because that will change the end behaviors of the graph. For the leading coefficient, what we care about is whether your leading coefficient is positive or negative. If your leading coefficient is positive, that will determine certain things. If your leading coefficient is negative, that will determine certain things. So, thinking about an even degree, let's just think about the most basic function with an even degree, which I would say is x squared. Alright, f of x equals x squared. You guys know what that function looks like. If we're talking about just x squared, that's the U shape, right? That's the positive parabola, the one that opens up. What I'm saying is, any single function that you can possibly think of that has an even degree and a positive leading coefficient, its end behaviors will be the same as this quadratic right in front of us, meaning it's going to rise as it goes off to the left, and it's going to rise as it goes off to the right. So even if it's a 2x to the fourth, it's still a positive 2, and it's x to the fourth power, that's even, so it will still follow the same trend. It may look different in the middle, but we're not worried about the middle right now. On the other hand, if we talk about an even degree function that has a negative leading coefficient, well, the easiest one for that would probably be negative x squared, right? It's a 2 for the degree. 2 is the highest power because it's the only power, and we just have a negative 1 in front. Well, we know that that is just the upside down version, right? It's an upside down U. It's a hill instead of a valley. And so what I'm saying is, anytime you have an even function with a negative leading coefficient, or an even degree, I mean, with a negative leading coefficient, it's going to fall left, going down, and it's going to fall right. For the odd functions, I guess I'd think about an x to the third probably. Think about x to the third, a positive x to the third function looks like this, whereas a negative x to the third function looks like this. You may notice, as we're looking through these, that a positive x to the third function trends up as it goes from left to right. This function starts down here and then it slowly goes up as it's going from left to right. Whereas a negative cubic starts up at the top left and starts to slowly trend down as we look at it. So that could help too. Positive leading coefficient lets it trend up from left to right, and negative leading coefficient lets it trend down from left to right. But looking at that visually, you can see what our end behaviors would be. On the left side, as it's going off the graph on the left side, it's falling. And as this graph trends to the right, or goes to the right, it's trending upward. So it rises right. And then the other one is the exact opposite. It's going to rise as it goes to the left, and it's falling as it goes to the right. Those are the only 4 end behaviors that you have to know right there. Now obviously you're going to have to memorize this chart or memorize the rules because I'm not giving you it on the test. But these are the only 4 options that you have to look from. So the idea of this, what I'm talking about with this, is I'm saying, imagine that I gave you some random function. 2x to the 5th plus 6x to the 8th minus 3x to the 9th plus x minus 7x squared. Completely random, just making up random crap right now. I don't expect you guys to be able to graph that. Make that very clear first off. I'm not going to ask you to graph a function like, I didn't ask you guys to graph a function like this the entire last week. That lesson's still coming to talk about something like this. But what I am saying is right now we can figure out what this graph is going to do on the outsides, as on the leftmost side of the graph, on the rightmost side, as it's going out of our sight, when it starts just going in the same direction for the rest of its time, right? Because the domain of this function is negative infinity to positive infinity, right? There's no radicals or fractions or anything messing with the domain, so it's going to be going left and right forever. So at some point, if we looked at the graph of this, it's going to start going in one direction as it goes to the left, whether that be up or down, and it's just going to keep doing that, and we don't really care what happens after that. So what we need to do is we need to find the degree of this function, and we need to find the leading coefficient of this function. Degree would be the highest exponent that we have. Well, highest exponent I see is the 9 right here. So it looks like our degree is 9. Now remember, looking at this chart that we talked about, all I care about is whether our degree is even or odd. 9 would be an odd number. Because 9 is my degree, my leading coefficient has to be the number that is with that in front of that x. So it would be this -3 right here. Looking at our chart, the only thing I care about with my leading coefficient is whether it's positive or negative. In this case, it's certainly negative. So, if I have an odd degree and a negative leading coefficient, that would mean I'm looking at this bottom right part of my chart. So it would be, I'd be thinking of it as if it was a negative x to the third, or in general, like we talked about, a negative odd degree function. If it's negative, it's going to be trending downwards as it goes from left to right, which means it should be starting in the top left. So it would be rising being the up direction. It's rising as it goes left, but it's trending downwards as we go along, which means it's going to be falling as it goes to the right. Those are in behaviors. That's all I'm asking you to find for this lesson. To be clear, what that means is I do not know what this graph looks like. I have no idea where it's going to cross the x-axis. I don't have any idea what its y-intercept is right now. I mean, I can kind of figure that out quickly because you just would plug zeros in for the x's. So this one looks like it's probably crossing through 0, 0 since I haven't put any constants. But we're ignoring all of that. All I'm saying is for sure there is some point on this graph where it starts going up and it's going to do that forever. And there's some point on this graph where it starts falling to the right, and it's going to do that forever. I have no idea what's happening in this area right here, but at least I know the end behavior is what the graph's going to do as it goes out of my sight. The other lessons we'll talk about what we want to do to graph the middle parts.